Hello friends, welcome back my YouTube channel MS Maths. In this video, we are going to discuss about the topic solution of ordinary differential equation by using Laplace transform. If you just want to see the concept, what is the concept, know the concept, you can watch my previous video. I have discussed totally the when we have the constant coefficient differential equation, then how to solve by using Laplace equation. But there is a condition: we can only use the Laplace transform of the method in the differential equation solution whenever we have the IVPs or BVPs. Like see here, if we have these types of condition here, then we can use the different Laplace transform of the differential equation. Okay, solution of the differential equation by using Laplace transform. Now come to the first question, and we will take two questions and I will discuss complete two questions. One question is that and one question is this. So now first of all, what is the process to solve the differential equation? First I am taking the Laplace transform and then solve this, putting the IVPs and then taking inverse Laplace transform. Now first here I am letting this is equation number 1. So I can write this equation like as this is nothing but 2d2y plus 5dy plus 2y is equals to e power minus t. Okay, here d is nothing but d by dt with respect to t derivative. Now I am considering this is equation number 1. Now taking the Laplace transform both sides of the equation number 1. This is equation number 1. So now 2 Laplace, okay, there is no 2 bracket, okay. Now 2 Laplace of d2y plus 5 Laplace of dy plus 2 and Laplace of y and Laplace of e to the power minus 2t. Consider, let y, Laplace of y is nothing but y bar. I am taking this is a y bar. Okay, so now here 2 Laplace of this is the s square into y bar minus s y0. This is the theorem, derivative, Laplace transform of derivative, and minus this is nothing but y0 only, and plus 5. Okay, s, there is degree 1, then it is s y bar minus, or it is y dash 0. Okay, consider it is y dash 0 and it is only y0. Now it is y0. Okay, now this is the Laplace transform of the plus y bar. Laplace transform is y, and this is 1 upon s plus 2. Like the Laplace transform of e to the power at is nothing but 1 upon s minus a, and a is here minus 2, so this is nothing but s plus 1 by s plus 2. Now we have this equation, and now we will put here the IVPs, and we have the condition like these two values are 1. So 2 into by using IVP. Okay, by using IVP, so s square y bar minus s, and this is 1, this is also 1, plus 5 here, this is s y bar minus this is 1, and simply this is 2 y bar is equals to 1 upon s plus 2. Now taking here, I can write 2s square y bar minus 2s minus 2 plus 5s y bar minus 5 plus 2 y bar is equals to 1 upon s plus 2. I can take y bar common because I just want to free the y bar. So this is the Laplace transform, and I can take inverse Laplace by using to get the solution of the differential equation. Okay, so now y bar is nothing but 2s square plus 5s plus 2, and the constant term is remaining here, so it is minus 2s, and this is minus 7. It is 1 upon s plus 2. Okay, now I can write this term y bar 2s square plus 5s plus 2 is equals to 2s plus 7 plus, okay, yeah, this is the minus, and 1 upon s plus 2. And by using this is here like this, y bar is equals to, okay, the y bar is equals to 2s plus 7 upon 2s square plus 5s plus 2 plus 1 upon s plus 2 here, and s is 2s square plus 5. This is 5s plus 2. Now like the work of different like Laplace transform is end here. Now we have to take the inverse Laplace transform, but before going there, that we have to calculate this term, or we have to free or for like form a different like form a standard Laplace transform. So for that we have to uh, solve this thing. Okay, now I'm taking Laplace inverse. So basically I'm going to solve this thing here. Firstly 2s plus 7 upon, okay, firstly I can solve this 1 upon, this is the 1 upon s plus 2. Yeah, we can solve easily like both of them. Then s plus 2, 2s square plus 5s plus 2. Now we have to partial fraction this term, and how can we partial fraction? See here, first of all 1 upon s plus 2, and we can fraction this thing like that is s square plus 2, and this is from 2. Okay, let me check. Okay, thing here. Now next what will be the term? 1 upon 1 upon s plus 2, 2s square plus 5s plus 2, and we can fraction this term. Okay, so like it is nothing but 2s square plus 5s plus 2, then 2s square plus, it will be the 4. Okay, so 4, then 2s plus 3s, but not, it will not 4. So s plus 2 or 2s plus 1. I think this is like 2s square plus s plus 4s. Yeah, s plus 4s. Okay, s plus 4s. Okay, this is the fraction for this, and it is nothing but 1 upon s plus 2, and s plus 2 is also here, so it will be the whole square, and 2s plus 1. Okay, now fine. So this will be the term. Now we have to partial fraction like this term, or like there is no need to find the partial fraction. We can take the Laplace transform, inverse Laplace here. If I'm going to solve the inverse Laplace, then so 1 upon okay, before going to partial fraction, we can do one thing. Like there is a s plus 2, there is a shifting by 2. We can also make it there. Here is also shifting, then Laplace inverse of 1 upon s plus 2 whole square, then 2s plus 2 minus 2 plus 1 here. Okay, now it will be the form of shifting, like e to the power minus 2t Laplace inverse of 1 upon s square, and it is nothing but 2s, and this complete thing I'm taking only this plus, so minus 2 plus 1. Okay, no problem. Like see here, this is the I'm adding 2, and I'm adding 2 and subtracting 2. So due to that, like this term is here, like shifting properties here, shifting is here. Okay, and minus 2 became we can take outside, because like we have the formula of the e is nothing but 1 upon s, and I can write this thing like this thing. Okay, and here we have this. Okay, now e to the power minus 2t, and Laplace inverse of 1 upon s square, and I'm multiplying this thing is here 2s 4 plus 1 minus 3. Now here if I'm taking like s 2s minus 3, if there is a s square, then we have a theorem Laplace transform, that is integration, and if we have divide, if we have s term in divide, then we can easily create this term by using this. Okay, now I can write this thing is like this 1 upon 2s minus 3 minus 1 upon s, or s minus 2s plus 3. I need, here is 1. Okay, I need this, like there is 1, then I can multiply this 2 and divide by 2. Okay, no problem. 1 upon 2, and I am putting here 2, like this is the trick, hit and trial method. Okay, 2, and here is 1. Now if you calculate this thing, then this and this got cancelled, but there is also remaining 3, then 1 upon 3 is multiple. So this is the partial fraction of this term, and you can calculate also by this. If you want to calculate like ordinary method, then a upon 2s minus 3 plus b upon s, you can also calculate by this method, but I am using the hit and trial method to solve the partial fraction. Now here we can easily calculate 1 by 3, 2, if I am taking 2 common here, so it is s minus 3 by 2, because 2 and 2 got cancelled, and it is 1 upon s. So now taking the Laplace transform of this thing, so this is the 1 by 3, and it is e to the power plus 3 by 2. Okay, s minus s plus 2, e to the power minus 2, so s minus something to e to the power 80, or it is Laplace transform 1 by s is 1. So this, the Laplace transform of this thing is this. Now here we have to create this term. So now if we just want to create this term, we have to integrate. If we divide any s here, if I am dividing any s here, that will automatically multiply here, then it is nothing but 0 to t e to the power 3 by 2x minus 1 dx. Okay, we have to integrate this term. So it is the e to the power 3x by x upon 3x by 3 by 2 minus x, and now put here 0 to t. So it is the Laplace transform of only this term. So this question is very important. Okay, now here 0 to t, and if I am putting the limit here, then it is 2 by 3 e to the power 3 by 2 into t minus t, or if I am putting 0 here, minus e to the power 3 or 2 by 3, 0 0. Okay, lower limit, on putting the lower limit. So this will be the Laplace transform of only and only, so 2 by 3 e to the power 3 by 2 t minus 1 minus t. So it is the Laplace transform of only and only this term. Now we have to calculate the Laplace transform of this. So by using these, like this thing, I'm putting the just like idea of the questions, like how can we solve the differential equation. So this question is very important. Now this term we can write here, 1 by 3 is also here. Okay, so this is the thing, like you have to multiply this here, so it is 1 by 3, you can write 1 by 3 here, because there is a 1 by 3, 1 by 3, then 1 by 3, and 2 by 9 also here, 2 by 9, you can write 2 by 9 here, and 2 by 9 is multiplied to whole thing. So this is the Laplace transform of complete this, because there is a 1 by 3 is also here. Okay, now like the Laplace transform of this 2s plus 7 upon 2s square plus 5s plus 2 is nothing but the inverse Laplace transform of this is 2 e to the power minus t by 2 minus e to the power minus 2t. Okay, I'm writing this directly. You can solve easily by using this term or this method. Okay, you can create this term. Okay, the fraction is nothing but s plus 2, 2s plus 1. Okay, you can easily create like this term, and by putting the integration property here, like this is the very important, by putting the integration property here, you can solve this. So by using this, the Laplace transform is nothing but 2 e to the power y e to the power t by 2 minus e to the power minus 2t plus 2 by 9 e to the power 3 by 2t minus 1 minus t. So this is the solution of this differential equation. I'm just putting the idea how to solve the differential equation by Laplace transform. Okay, so this is your work to solve this thing. Now come to the next question. Now next question is nothing like pretty tricky here, like there is also a twist here. So first of all, we have to take solution y double dash. So I can write this y double dash, let first of all let Laplace transform of y is nothing but y bar, and I can write this is the s square y bar. Okay, s square y bar minus s y0 minus y dash 0, and put here 25 y bar is equals to 10. Like taking Laplace transform of this thing, cos 5t is nothing but s upon s square plus 25. Okay, s upon s square plus a square. Now we have IVP, s square y bar minus s, this value is 2 and this value is 0. Okay, no problem, and plus 25 y bar is equals to, we have this value. Okay, we can easily write this term s square plus 25 here. Now taking y bar common, so it is s square plus 25 also here. Okay, s square plus 25 minus 2s. Okay, now there is no y bar, so it is 2s is equals to 10s upon s square plus 25. Okay, now s square 10s plus s square plus 25 here. Now here y bar is equals to 2s upon s square plus 25 plus 10s upon s square plus 25 whole square. Okay, no problem. Taking Laplace inverse, taking Laplace inverse, so it is y bar is equals to Laplace in not y bar, it is y only, 2s upon s square plus 25 Laplace inverse of 10s upon s square plus 25 whole square. Now see here, I'm writing this term is here, like I'm taking 2 common, like 2 outside, so it is nothing but s upon s square plus a square, so cos of, so it is cos formula, so it is cos of 5t. But what about this whole square and 10s also? So I'm just taking, like we have like same this property, not, yeah, like same this property something. If I'm taking the Laplace inverse of sine 5t, it is nothing but 5 upon s square plus 5 square. Okay, now here is s square plus 5 square whole square. It means not this integration property, here is the multiplication of s is in numerator. If is s in multiply in denominator, then we will integrate, or if s is in a multiplication in a numerator, then we will differentiate this thing. So on differentiating, the Laplace transform is nothing but minus 1 power the derivative. How many times you have, you will like differentiate this thing? 1 times. So okay, minus 1 power 1. Okay, and dy dx of 5 upon s square plus 5 square. Okay, now taking 5 outside, minus 1 power 1. See, this is 1 upon x square. So 1 upon x square is what? Minus 1 upon s square plus 5 square. The derivative of 1 upon x is nothing but minus 1 upon x square. So x is nothing but s square plus 5 square. And if I am going to derive further chain rule, so I am getting this minus minus plus, then 10s. Okay, 10s upon s square plus 25. So by on the like derivative, we have to multiply here. Okay, Laplace transform of t sine 5t. If we multiply t here, t power 1, t power 1, then we'll derivative 1 times. Okay, so it is nothing but the Laplace transform of Laplace inverse of t power 1 sine 5t. Okay, so here will be the t power 1 sine 5t. So this is nothing but the theorem, and it is important theorem. I hope you are getting this question or this question. These are very important question. Because of that, this Laplace inverse, like how can we find the inverse Laplace, that is the important thing. Okay, so thanks for watching my video. Keep watching MS Maths, and for more videos you can subscribe the channel, watch the share the video, like the video. Thank you. Bye bye.